This video is designed to introduce you to the anatomy of the pyramid and to teach you how to find its lateral and surface areas. Although most of you are familiar with the term pyramid, let's take a look at its definition in pure mathematical terms. A pyramid is going to be a polyhedron with triangular faces and only one base. And that's big. That's different than our cylinder and our prism that we've studied so far. So the pyramid contains only one base. Those triangular faces are all going to meet at a common point called the vertex of the pyramid. Just like prisms, we name a pyramid based upon the shape of its base. Now, a regular pyramid is going to be a pyramid who has a regular polygon for its base. And because its base is a regular polygon, the lateral faces of this are all congruent isosceles triangles. So if we take a look at the diagram and talk about some of those words that we just talked about, the triangular lateral faces are going to make up the sides of your polygon, or sides of your pyramid. The base is going to be a polygon, and notice that there's only one base. The vertex is going to be the point at which those triangular lateral faces come together. So now that you've mastered the lateral faces, the base, and the vertex, let's talk a little bit about slant height and altitude. Now, because the shape of the base for this pyramid is a pentagon, we would say that this is a pentagonal pyramid. So again, just like the prism, the pyramid is going to be named for the shape of its base. The slant height of a regular pyramid is going to be the distance from the vertex measured down one side of the pyramid. So in my picture over here, slant height is going to be that picture in my triangle. And if you consider those lateral faces to be isosceles triangles, you might even say that the slant height is the same as the height of one of those triangles that makes up the lateral faces. The altitude is going to be the distance from the vertex down to the very center of the base. Remember, sometimes altitude is called height. In order to find the lateral area of a regular pyramid, we're going to find the areas of these individual isosceles triangles that make up the faces, and then add them together. Just like with the prism, the lateral area of a pyramid does not include the area of the base. The surface area can be used by adding all of the lateral areas from all the faces together with the area of the base. So again, just like the prism, lateral area does not include the area of a base, but surface area does include the area of a base. All right, so let's go ahead and put all these ideas together and solve a problem. They give us this regular pyramid, and they tell us that the height or the altitude of this regular pyramid is 8 feet, and the base length is 12 feet. They want us to find to the nearest tenth the lateral and surface areas of the pyramid. So if I look at this picture, my height or my altitude is 8 feet. That's going to be the distance from the vertex down to the very center of the base. So that distance right there, I'm going to mark in my picture with an 8. Base length is 12 feet. So base length is going to be the length of any one of these bases. They're all going to be the same because they tell us in this problem that this is a regular pyramid. So if one of them measures 12 feet, I could go ahead and label all of them 12 if I so desired. And again, they want us to find both the lateral and surface areas of this pyramid. Well, the lateral area is made up of those 4 isosceles triangles. So if I could find the area of just one, I could then multiply it by 4, and that would give me the lateral area. So I'm going to go ahead and isolate one of those isosceles triangles that make up my lateral faces. I know from my picture of the pyramid that this base edge measures 12. And if I want to find area of a triangle, I need to use the formula 1/2 times base times height, or base times height divided by 2. So I need to know the base of my triangle, which in this case is 12. But I also need to know the height of my triangle, which in this case, I don't know. So the problem becomes, how can I find that segment that represents the height of my isosceles triangle? Well, if I go back to my big picture of my pyramid, here's the height of my isosceles triangle, also known as the slant height of the pyramid, which I'm trying to find. I know that this height of the pyramid is 8, and if I connect that bottom of the pyramid with the bottom of the triangle, those two guys, the green segment and the purple line segment, are going to form a right angle. I know that the entire base edge is 12. And if the whole thing is 12, then the distance from the middle to the edge is going to have to be half of that, or 6. So now I've got a right triangle made up of the green line segment, the purple line segment, and the red segment. I know that the two legs of that triangle are 8 and 6. To find the third leg, I can do a little Pythagorean theorem. And you can do this for the slant height on any pyramid. So when I punch 8 squared plus 6 squared into my calculator, it tells me 100. So C, my slant height, or my hypotenuse, can either be positive 10 or negative 10. Because I'm talking about length here, I'm going to reject the negative root. But now I know the slant height of my pyramid is 10, and the slant height just happens to be the height of that isosceles triangle. So now I have all the pieces that I need to go ahead and find the area of each one of those isosceles triangles. So I'm just going to plunge 1/2 times 12 times 10 into my calculator, and it tells me 60, and this is area, so it's going to be square units. So now going back to my lateral area is made up of 4 of those isosceles triangles. So my lateral area is going to be 4 times the 60 square units that are in each, or 240 square units. And I'm going to say square feet because they give me dimensions in this problem. So there's my lateral area. My surface area, on the other hand, is going to be made up of the lateral area plus the area of my base, which, just like in the section on prisms, we always talked about area of the base and represented that in the formula with the capital letter B. I'm going to do the same thing for these pyramids. So the surface area is going to be the 240 square feet that I found for the lateral area. And to that, I'm going to need to add the area of my square base. Well, to find the area of a square, I'm going to do length times width, or base times height, or side squared, however you want to think about this. My length and width are both 12, which tells me the area of my square base is 144 square inches. So all in all, when I combine the lateral area with the area of my base, I end up with 384 square inches. All right, so I would, if I had to pick some key ideas from this, I would say use Pythagorean theorem to find the slant height. I would say to remember that lateral area consists of isosceles triangles, and the number of them will depend on the shape of your base. And I would remember that lateral area, like the prism, does not include the area of a base. Surface area does include the area of a base. But there's a chance for you to summarize in your own words the key ideas and important understandings from the video. And then what I want you to do is see if you can apply what you learned in this video to solve questions 2 and 3 on the following page.